Welcome back to our lesson, and let's continue with our lesson. So now we are going to look at the second concept of this lesson, and those are polynomials, where we are going to look at monomials, binomials, and trinomials. Let's start with the first one, monomials. Remember what a monomial is. It is an expression with one term only. Exponents of variables should be positive integers. So for example, 2x cubed. Now, let's look at more examples of a monomial. We have 6x exponent 4. We have 12q. We have 42k cubed. Or we have ABC. These are examples of monomials, only one term. What about binomials? Now, a binomial is an expression which is a sum of two terms. Exponents of variables should be positive. For example, 2x cubed plus 20. Two terms only. So more examples of binomials. We have 6 plus 3x exponent 4. We have 1 minus 5q. We have 4x minus 2k cubed. And we have a squared plus 6a, only two terms. Let's look at trinomials. A trinomial is an expression which is a sum of three terms. So exponents of variables should be positive. For example, 2x squared plus 5x minus 2. Let's look at more examples of trinomials. Now we have there 6x cubed plus 3x exponent 4 plus 1. That's a trinomial. Or we have 1 plus 7q squared minus 5q, three terms. We have 4k minus 3 minus 2k cubed. Or lastly, we have a squared plus 6a plus 5. So those are examples of trinomials, three terms. Let's move on to the next concept of our map, the last concept of our map, which is going to be expand and simplify algebraic expressions. Now, we are going to be looking at like and unlike terms. Like terms are terms that have the same variable as the base and the same exponents to that base. For example, 2a and 5a are like terms. So in the following expressions, we are going to identify the like terms, just so that we can see which ones are like terms. So the first one there is 6ab plus 7a squared minus 5ab plus 2a squared. Remember how we look out for like terms? They need to have the same variable and the same exponent to that variable. So let's look here. We have 6ab and 5ab. Those are like terms. Why? Because they both have ab as their base for the variables, and both a and b have 1 as an exponent. So they are like terms. We also have 7a squared and 2a squared as like terms. Let's look at the next one. Can we identify the like terms? Yes, the like terms are 19x and 16x. Let's look at the next one. Which ones are the like terms in this case? If you are looking at 31y cubed and 25y cubed, then you are correct. Those are like terms. What about 3xy and 12xy? Are they like terms? Yes, they are. Why? Because they both have x and y, and the exponents there are also the same. Lastly, we have a 5 and a 4, and those are also like terms. Why? Because they are both constants. They do not have any variables with them. Let's look at the next one. Which ones are the like terms in this case? We can see there 3p squared and 2p squared. Yes, they are like terms. What about the 6pr and the 6rp? Now, it might look like they are not like terms, but they actually are. Why? Because both of them have P and R as variables. Remember, multiplication is commutative. So whether it is PR or RP, it is the same. So yes, they are like terms. And then we are left here with 6R squared. That one doesn't have any like term or anything that is the same as it, so it will remain that way. So let's go on to addition and subtraction of terms. Now, when we add and subtract terms, they need to be like terms for us to be able to add or subtract them. Let's look at the first one. We have 6ab plus 7a squared minus 5ab plus 2a squared. We've already identified 6ab, or let me rather start with 7a squared. We've already identified 7a squared and 2a squared as like terms. Now we also have the 6ab and the 5ab. So now we have 7a squared plus 2a squared, that is 9a squared, and we have 6ab minus 5ab, that will leave us with just 1ab. Let's go on to the next one. 19x minus 12x cubed minus 16x. Now we've already identified 19x and 16x as like terms. So let us just write them next to each other so that it is easier for us to calculate them. I'm going to start there with the negative 12x cubed, and I have now the 19x and the 16x. So negative 12x cubed. What is 19x minus 16x? That is going to leave us with a 3x as our answer. Let's go on to the next one. We have the 31y cubed plus 5 minus 3xy minus 25y cubed plus 12xy minus 4. Again, here we had already identified the like terms. We said that 31y cubed and 25y cubed were like terms. Then we also have the 3xy with the 12xy. And lastly, we have the constants, which is the 5 and the 4. So if we are going to add our like terms here, that is 31y cubed minus 25y cubed, that gives us 6y cubed. And then negative 3xy plus 12xy, that is going to give us a 9xy. And then we have 5 minus 4, that leaves us with a positive 1. And that is our answer. And as you look at the answer, there should be no more like terms left to show that we've added or subtracted all the like terms. Let's look at the next one. We have the 3p squared minus 6pr plus 6r squared minus 6rp plus 2p squared. Now 3p squared and 2p squared are like terms. Then we have 6pr and 6rp, of which we said we've identified them as like terms. And lastly, we have the 6r squared. So 3p squared plus 2p squared, that is 5p squared. Then we have a minus 6pr minus 6rp. Because they are like terms, we are going to add them. So that is a minus 6 minus 6. That gives us a minus 12pr. And lastly, we have that 6r squared. So that is how we add and subtract our like terms. I hope you understood everything and enjoyed this lesson very well. That is the end of our lesson. We hope to see you next time. Goodbye.